Question 6. Table 2 shows some standard electrode potential data. Use Table 2 to deduce the species that's the best oxidizing agent. Well, the reaction that goes ahead the best is the top one. It's got a plus value of plus 1.36, the highest positive value. So its electrode potential is the highest. So this reaction, Cl2 plus 2 electrons going to 2 Cl minus, is the one that goes ahead most readily. So let's have a look at Cl2. It could be Cl2 or it could be Cl minus that's the best oxidizing agent. Let's work it out. So this one, Cl2, is definitely going to go ahead to make Cl minus very, very strongly. So Cl2 gas plus 2 electrons, oil rig, remember, oxidation is loss, reduction is gain, it's gaining electrons, this is being reduced. Another way of looking at it is that Cl2 is an oxidation state 0. It's an element on its own with no charge, and Cl minus is oxidation state -1. It's come down, it's gone from 0 oxidation state down to -1. It's been reduced. If it's been reduced, when that is reduced, something else is oxidized. That's called a redox equation. So when this is reduced, something else is being oxidized. We know it gets reduced because it's got a large electrode potential. We know this is going to go ahead, so it will be reduced very readily, and therefore it will be a very good oxidizing agent. Cl2. Write the conventional representation of the cell used to measure the standard electrode potential for the conversion of tin 2 into tin. Tin is Sn2+, that's tin 2 ions, and tin metal is Sn. So a standard electrode potential is called the hydrogen electrode potential. You use a platinum catalyst. So the cell is Pt. You always put the platinum catalyst. You name the electrode rather, not the catalyst, the electrode, platinum electrode. The platinum electrode is Pt. Hydrogen going to H+. So you've got hydrogen gas going to H+. You always, the left-hand cell is always the oxidation half. So 0 oxidation state up to +1, it's being oxidized. So that's always your standard electrode cell. The other half then is your reduction half. So Sn2+ going down to Sn, 2+ oxidation state going down to 0. Another way of looking at it is that you always have the ions in the middle, so things with pluses in the middle of the representation. The cell was made by connecting 2 half cells with a salt bridge. 1 half cell consisted of silver in silver nitrate solution. So we're talking about this equation here, Ag plus an electron going to Ag solid, silver in solution going to form silver metal. And the other consisted of tin in a solution of tin 2 nitrate solution. So tin and tin 2. So we've got to get a positive value overall. We can reverse one of these. We need to reverse one of these so that we end up being able to cancel out electrons. We can't have 2 reduction equations. We're going to have a redox. One's got to be reduction, one's got to be oxidation. So which one are we going to reverse? Well, we'll reverse the sign, we'll reverse the equation, and when we reverse the equation, we reverse the sign. And we need to reverse the equation and reverse the sign so that when we add these 2 values together, it gives a positive value. So the bottom one is the one to be reversed, because if I reverse that round from Sn2 plus 2 electrons to make Sn, reverse it round so that Sn makes Sn2 plus and 2 electrons, that value will be plus 0.14, and when I add the 2 together, it will be plus 0.94. And that's my half equation. Occurs at the negative electrode. I know I'm talking about this equation occurring at the negative electrode because electrons are made at the negative electrodes. Electrons are minuses. That's why the electrode is negative, because electrons are made there. And so it's talking about the oxidation half equation, where it's making electrons. Oxidation is loss. So oxidation is loss of electrons. So that's an oxidation half equation, or you could say it's going from oxidation state 0 up to +2. The oxidation state is going up, an oxidation half, making electrons and making the negative electrode, making the electrode negative. Use the data from table 2 to write an equation for reaction of silver ions with iron 2 ions. So silver ions, and I've got iron 2 going to iron 3, so I've included iron 2 ions, and I've got silver ions. What's the equation that's going to go ahead? Which one am I going to reverse? I'm going to have to reverse the bottom one again to give minus 0.77. So when I add the two together, then it gives me a positive value then of 0.03. So two half equations are this one staying in the same direction, Ag plus an electron. This one is being reversed, Fe2 plus going to Fe3 plus an electron. Take everything on the left and everything on the right. So Ag plus an electron plus Fe2 plus, Ag plus Fe3 plus an electron. Electrons cancel, and that's my overall equation.